All right, in this second video, we're actually going to take what we learned about inverse variation from our Chicago-Minneapolis problem, and we're going to answer some problems that are similar to the things that you'll be doing in your lesson and quiz and test, etc. So, first thing to note, inverse variation, two variables, x and y, show inverse variation if they're related as follows. Well, in the previous video, we talked about there being some constant here that was divided by x or input, and it would give us y or output. Now, A is what your textbook, that again we don't really use, has. You'll also often see the letter K here, so y equals K over X. I think when you do pre-calc next year, it'll be a K. So K for constant. Either way, there's some value there, some number that's going to go right here. That constant, A, K, whatever you want to call it, is the constant of variation. And y is said to vary inversely with X. Okay. Instructions tell us the variables X and Y vary inversely, and y equals 15 when X equals 1/3. Write an equation that relates X and Y. Okay. If they vary inversely, then I know that, just for starters, y is going to equal some number divided by x. I'll use k, you could use a, it doesn't really matter, okay? And I'm told that y equals 15 when x equals 1/3. All right, so as I look at this equation setup, I've got three variables, x, y, k. Now I'm going to play the algebra game of plug stuff in to figure out what I can solve for. So if y equals 15, so 15 equals k, some number, divided by x. Well, x is 1/3 when y is 15. So something divided by 1/3 equals k, or equals 15, excuse me. So solve for k, figure out what that is. All right, if I'm going to solve for k, I'll multiply by 1/3. And again, I'm not going to multiply by the reciprocal here because I'm actually trying to undo division by 1/3. So I multiply both sides by 1/3. That cancels over here. I got just k equals 1/3 times 15. Well, that means that k must equal 5. Okay. Now, that isn't an equation that relates x and y. That's not the answer. This is just part of the answer. Here's what the answer is going to look like. Okay. Remember, I had y equals k over x. Well, this is the value k that makes this equation work. So here's the equation. Here's my answer. Y equals 5 over x. That would be my equation that relates x and y, given that y is 15 when x is 1/3, and given that they vary inversely. So this is what the answer is going to look like, okay? An equation. Boom. Now, part B in a lot of these problems are going to have a second part. It says find y when x equals -10. Well, if I know that x and y are related this way, if there's a different x value, what's a different y value? Okay, well, take that equation and think about what you get when you plug in -10. All right, 5 divided by -10, well, that would be -1/2 or -0.5, okay? So that would be the second answer to my problem. And a lot of the things that you'll be doing to practice are going to involve two things. Find an equation that relates x and y, use that equation to find a new value, okay? We'll practice one more down here. Again, variables x and y vary inversely, okay? Y is 3 when x is 4. Okay, write an equation relates them. All right, so I start with my general inverse variation equation that I know is going to work, k over x. I don't know what k is, but I do know what x and y that match up. So I know that y equals 3 when x equals 4. Okay, solve for k. Instead of dividing by 4, do the inverse, which would be to multiply by 4. 4 times 3 is 12. 4 is over here, cancel, so that means that k must equal 12. Remember, that's not my answer. The equation is my answer. Here's my answer. Y equals the constant I just found, 12, divided by x. That's what I'm looking for an answer. Okay, there's an equation that relates x and y. Part 2, find y when x equals 2. Okay, well, plug it in. What does y equal if x is 2? Well, 12 divided by 2 is 6. So there's part 2 of my answer. Okay, a new y value given a new x value. So that's working with writing and using inverse variation equations.